Hello everyone. Today is going to be our first lesson and we're going to be starting off with section 1.2 in chapter 1. We're going to be skipping 1.1, so you could just ignore that in your workbook, and we're getting started with 1.2. So section 1.2 is greatest common factor and least common multiple. And our learning target for this section is to understand the difference between prime numbers and composite numbers, and to find the greatest common factor and the least common multiple of sets of numbers. Your toolkit for this section is basic division and multiplication, and then to also write repeating multiplication using powers. So just a refresher on that. Here we have a bunch of 2's and a bunch of 3's all multiplied together. So it's kind of hard to just look at this and to know what it's saying, so especially if you had even more 2's and 3's. So one way to simplify this is we're going to write out the two different bases. So here the base is the number 2 and the second base is the number 3. So we're going to write those out. Then we're going to count the number of 2's that we have. So we have 1, 2, 3, 4, 5. We have 5 2's. So I'm going to write 2 to the 5. And then we're going to count the number of 3's that we have. 1, 2, 3, 4. So we have 3 to the 4. Okay, so that's how you would simplify this using powers. The next thing to review is the difference between prime and composite numbers. Prime numbers are whole numbers, so it can't be a decimal, whole numbers that can be divided by itself or by 1. So 0 and 1 are not prime numbers. Those are special cases. So they're neither prime nor composite. So we're going to put those aside for now and be focusing on prime numbers only first. And the prime numbers under 10, you need to memorize. You need to be very comfortable with them. There's 4. So there's 2, 3, 5, and 7. So those are the prime numbers under 10. Oops. And so like I said, you really need to memorize these. It's very important that you are very comfortable with them. Some mistakes that people make are thinking things like numbers like 4 and 6, forgetting that those aren't prime numbers when we do the next section. So very important that you memorize these. The next set of numbers are the prime numbers between 10 and 20. So again, we have 4, 11, 13, 17, and 19. Okay, so it's also very important that you know these ones really well. You won't use them as often as the prime numbers under 10, but you still use them a fair amount, and it's important that you're comfortable with them. And then you should just be aware of what are the prime numbers under 50. So there's 23, 29, 31, 37, 41, 43, and 47. Okay? And prime numbers continue to infinity, just like as regular numbers continue to infinity. There's always going to be some prime numbers. Composite numbers are numbers that can be divided by more than just themselves or 1. Okay? And they're composed of several prime numbers multiplied together. And we can then decompose them to get those prime numbers back, figure out what they are. Okay? So for example, we have the number 12. And we can decompose 12 back into its prime numbers. That's called factoring. So where do I have space for that? On the side here. Okay, so here's 12. Okay, so if we think of numbers that can divide into 12, you might think of the number 3 can divide into 12. You might think the number 2, the number 4. So these are all factors of 12. I'm going to choose 2 to start with because 12 is an even number and 2 is always a nice, easy thing to divide by. So I like to, if something can divide by 2, I like to start by taking 2 off as a first option. So I write 2 on the left of my factor tree and I'm left with a 6 because 2 divided by 12 gives me 6. Now 6 is again an even number, so I can take out another 2. And then I'm left with 3. And then I'm going to look at that, 2, 2, and 3, and I'm going to check, are they in my prime number list? Yes, both 2 and 3 are here. So we have 2, 2, and 3. So those are all prime numbers. So 12 can be factored into 2 times 2 times 3, or I have 2 2s, so 2 to the 2 times 3. Okay, if I wanted to simplify that. So let's look at now some more examples. So the next one I'm going to do is 28. So 28 is again an even number, so I'm going to continue and take out 2 first. It's the simplest thing to do. So I take out a 2 and I'm left with a 14. 14 is even again. Took out a 2 and I'm left with a 7. So if I was going to write 28 as a product of its prime numbers, I write 2 times 2 times 7. And if I wanted to simplify that, I could write that as 2 squared times 7. And this would be my final answer for my product of prime numbers for 28. Okay, let's look at another example. Let's look at 96. So let's say I wanted to use the 2 method again, and I'm going to start there. So I see that 96 is even. I take out a 2, I'm left with 48. I take out a 2, I'm left with 24. Take out a 2, I'm left with 12. Take out a 2, I'm left with 6. 2, I'm left with 3. But this is not the only way to do this. You can factor things whatever way you like as long as the numbers make sense. So let's say I looked at 96 and I said, I know that 12 divides into 96, so I want to start off by taking out a 12. And I know when I divide by 12, I'm left with 8. Or maybe you have a number that's not even, so you can't take 2 out, and you need to take another number out. Okay, so 12 and 8. I can't, even though 12 is on my left-hand side, I can't leave 12 because 12 is not a prime number. So I have to further factor the 12. So for my 12, now I'm going to take out a 2 and I get 6, and then 6 can break down into 2 and 3. And then for 8, I'll do 2 and 4, and then 2 and 2. So these 2 trees look very different. And so when you're looking at the solutions, your tree that you've created might look very different than the tree that's in the solutions. Okay, that's not important. There's lots and lots of different ways you can make these factor trees. What is important, however, is your final solution, because regardless of what your tree looks like, your final solution should be the same. Okay, so let's look at here. For this factor tree, I have 1, 2, 3, 4, 5. So I have 96 is equal to 2 to the 5. And then I have 1, 3. I wrote this too high. Let's move it down. 96 is equal to 2 to the 5 times 3. Okay, so I have my 1, 2, 3, 4, 5 2s, that's here, and my 3. If I look at my other factor tree that I made, I have, again, 1, 2, 3, 4, 5. I have 5 2s, so that's the same, and then I have 1, 3 right here. Okay? And you can circle these prime numbers or you can highlight them. It's important that you making sure that the numbers that you're writing here are only prime numbers. Okay, you're only writing down prime numbers there. And that's my final answer for 96. So what I'm going to recommend that you do now, this is the end of this first video. You can, if you want to, you can directly move on to the next video and continue this lesson. Or what my recommendation is that you pause here, you go to page 19 in your workbook, and you try out number 8, A to H. And when you're doing 8, A to H, you'll be trying this product of prime factoring. You'll be trying that in that question. Okay, so I recommend that you do that next, or you can just move on to the next video if you prefer.